Okay, let's solve this trig equation. First thing we want to do is isolate our trig function. So get that root 2 over to the other side. Divide by 2. Sine of x equals negative root 2 over 2. Now remember, I can't just type this in my calculator and do an inverse sign. First off, I want exact answers. My calculator won't give me exact answers. Secondly, I need all the answers. Even if I did this, even if I said x equals inverse sine of negative root 2 over 2, that would only give me one possible answer, and there are an infinite number of answers. I want them all. So I have to find, this is a unit circle question, all the places on the unit circle where sine equals negative root 2 over 2. And there are going to be two of them. Trig functions or trig equations have twice the number of answers you would expect. So sine equals negative in two quadrants, here and here. Root 2 over 2's happen at the 45, so we know this is 225 degrees and 315 degrees. Or if we want to do this in radians, it doesn't matter, but it is, usually we'll do these in radians. Those are my pi over 4, so there's 1, 2, 3, 4, 5 pi over 4, 6, and 7 pi over 4. So x might be 5 pi over 4 or 7 pi over 4. But that's just in one revolution. Remember, any coterminal angle will have the same sine, cosine value, and so forth. So if I add an extra 2 pi, an extra 4 pi, an extra 36 pi, if I keep going around the circle, I'm going to land at these points again. So my full solution, I have to say x will be 5 pi over 4 or 7 pi over 4 plus 2k pi. And there are all the solutions. Okay, let's do another one. What if I have sine of x plus tangent of x equals 0? Okay, well, probably want to change that sine into, or that tangent into a sine over cosine. Now, in this case, I want to factor. I could, you might think, let's move this to the other side. You might think, let's do this. And then cancel out that sign, but you're going to lose solutions if you do that. That's not what you want to do. Never cancel out one of your x's. Factor. I could pull out sine of x, because there's a common factor of sine. That would give me 1 plus 1 over cosine of x equals 0. The only way two things can multiply to equal 0 is if one of those is 0. So either sine of x equals 0. I can solve that. Or, do it over here, 1 plus 1 over cosine equals 0. Okay, let's solve this one. Where does sine equal 0? I have to go all the way around the circle. So I'm going to draw the graph. Where does sine equal 0 between 0 and 2 pi? Well, at 0 and at pi. Remember, we're always going to get twice the number of answers we expect, except at the ones and the negative ones. At 1, I only hit 1 once at pi over 2. And I only hit negative 1 once. Everything else I hit twice. So I'm between here and here. I hit 0 twice. X could be 0 or pi. That's just in the first revolution. We'll come back to that. This guy. This says if I move that 1 over cosine equals negative 1. And I could just flip both fractions and say cosine equals negative 1. Where does cosine equal negative 1? That's right here at pi. The only time you don't get two answers out of a trig equation is at the ones and the negative ones. Between 0 and 2 pi, cosine only hits -1 once at pi. This says x equals pi. Same thing I had over here. So then my full solution, we're always going to write it like this: 0, pi, and then plus 2k pi.